Okay. So the limit as x approaches 74 from the left of t of x. This represents the taxes and sales tax for California. So officials raised the tax by 0.0125. And then it shows the sales tax since it was first established in 1933. T of x represents the sales tax in year x. Find the following. Okay, so part A, 74 from the left. What did you guys say? What does it look like? What do we? 5. Yep, from the left as we're approaching 74, it looks like it's approaching 5. So the answer is 5. What does it look like the limit of the taxes are as x approaches 74 from the right? It looks like 6, doesn't it? So this is 6. So then what can you conclude about the limit of t of x as x approaches 74? It does not exist. DNE. Okay? Does not exist. How about the limit as x approaches 80? It is 6. You don't see it on there, but you can assume that 80 is somewhere between here and it lands at 6, right? So the limit from both sides of 80 is 6. Do you guys know what your units are? 5, 6 cents. Yeah, you can write cents. 6 cents. Okay. Do you guys know what that, like, with, particularly in part C, this kind of tells us, oh, my thing is, sorry, I didn't realize this was frozen. My, you gotta let me know if I freeze that. Okay. So when I look at a graph that is a word problem here, when I say it doesn't exist, that kind of tells you like there was no in between, there was no incline going up to from 5 to 6 cents. It just jumped. So it was a jump in the graph, right? That's kind of what that tells us if the limit does not exist. Okay. Moving on. Okay. So I decided to combine 2 lessons in one because I think we can do it. We're going to learn about limits with tables and substitution. Substitution is real easy. So, okay, here we go. You will need your graphing calculators, so get your graphing calculators out. Oh no, that's not what I wanted to do. What? You may, yes. If you need to borrow one of mine as well, that's fine. Ah, why is it doing that? Okay. All right, that's as good as we're gonna get here. Okay. All right, ladies and gentlemen, if we have a graph, it's easy to find the limits, right? We're gonna find limits in all these different ways. We already used graphs. We're gonna today use table of values and substitution. Later on, I'm gonna teach you algebraic rules, limit rules, and trig rules and calc rules. Okay, so that's all the things that we can do to evaluate limits. So without the graph, we could look at this table of values. Let's say we didn't have this graph, and we say, okay, well, looking at a table of values, if I make it really small, I have 2.9 and then 2.99, and it's approaching 3.99. If I do x is 3.1 and then 3.01, it looks like it's approaching what value from the left and right? What does this limit look like it's approaching? From the left, it looks like it's moving toward what value? 4. And from the right, it's moving toward 4 as well. So I can conclude, hey, the limit of this function is 4 based on a table. So if you can't tell from a graph, another technique we have is just check out the table of the graph, okay? So that's what we're gonna do next. We ready? Okay, I have some graphing tips here. on the side if you need those. So we're going to go ahead and find the limit of x cubed minus 1 over x minus 1 as x approaches 1. So get your graphing calculator up and go ahead and type the function in. So we're going to go to the y equals button and we're just going to type in our function. Do you guys know you could use if you type this in as is, you would have to use parentheses around the numerator and denominator. Do you guys remember how to get that fraction? Remember what you push? Alpha. Anybody remember? F1. Alpha F1. And then you get, you see this n over d, it'll give you a fraction. So you can just type it in. That's probably the nicest way. If you forget, you just put parentheses x cubed minus 1, parentheses divided by parentheses x minus 1. Okay.
It's just alpha and that's like the xt beta.
I see. Oh, xt theta n.
You just said
Oh,
alpha.
does yours have that? Yeah. Oh, okay. Nice. Does mine? I don't think mine. Oh, yeah, mine does that. So do you see it? Do you see that xt theta n key, the fraction bar? That's another way to do that. I didn't see that. So if you do alpha xt theta n, there you go. That's nice. I like it. I never noticed that. Okay. So type in your function either way, x cubed, and then get out of that exponent minus 1, and then divided by. So when you write it as a fraction bar, you don't really need to use parentheses, which is nice. Okay. So now go ahead and hit graph. And we're really not concerned about the graph. We're going to check out the table. We're wondering as the limit, as x approaches 1, what is the limit of the function as x approaches 1? So what you're going to do is you're going to go to, do you guys remember how to find the table? Do you see the table right above graph? It's like second graph. So you hit second graph, which is your table. And you can like check out your table, but do you see it counts by ones, right? And then at 1, it shows you there's an error, right? Right now, look at your y values, 7, 3, 1, 1, 31, 12, 13, 7, error. We don't really know. There's a lot between 1 and 7, isn't there? So we need to narrow this down by making our, the value that we count on the x's very small, right? So that's called delta x, right? The amount, the change in x. So do you remember how to get to delta table? Do you guys remember the shortcut? I taught you this a while back in our math boot camp. Do you know what button to press? There's a nice shortcut. Nope, it's not math. Usually it is. So everybody go ahead and scroll down to make sure you're highlighting x equals 1, because whenever you change delta table, the shortcut is, everybody look at the plus key. If you just hit plus, delta table will show up. And that will tell you, hey, like, you can type in whatever you want the difference in x's to be. So let's say, do you see the values I want here? I want 0.997, 0.998. I'm using hundreds, right? So let's say I want delta table to be 0.001. 0.001. Did I say hundreds? I meant thousands. I'm sorry. Okay. And hit enter. And your table, do you see how it changes? Isn't that nice? Now, look at your y values approaching from the left, from 0.997. What's my y value at 0.997? We're going to write this down. 2.991. And then at 0.998, it's 2.994. And at 0.999, it's 2.997. Now let's look at the other side. 1.001 is 3.003. 1.002 ends up being 3.006. And 1.003 is 3.009. Okay, now we can safely conclude what our limit of this function is. What do you think? What is the function approaching from the left? It's approaching 3, right? 2.997 is super, super close, right? And what is it approaching from the right? Is it also 3? Yeah. So the limit of this function, we didn't have to do any math other than looking at the table, is 3. Does that make sense? Okay. Hey, let me show you really quick another way to get to delta table. If you forget the shortcut is plus. So you might want to write delta table. This is a good note. Use the plus key. Okay, that's the shortcut. Another way to get there is, let's say you're, let's say we want to get back and you have to go to a whole number. Make sure you go to a whole number and then hit plus and go back to make delta table 1. Everybody do that. Go to the whole number of 1, hit plus, make delta table 1, and it works out really nice. Here's what happens if you, I'm going to go back to 0.01. You can keep yours on a whole number. If I'm on some random number and I'm like, oh yeah, I want delta table to be 1, and I'm on some random number, oh no, it's going to keep those decimals, right? Let's say your table's all messed up. Here's what you do. Do you see this table set above the window key? That table set? You're going to hit second table set, and you want, okay, table start. I just want to start on x equals 1. And then my delta table, I want to be 1, right? Down there, I'm good. And then I can go back to my table and it's good. Okay? So those are some tricks of the trade. All right. Example 2. Let's do this one. Okay, so type in your function, go to the y equals button, clear your function there. You can hit alpha x t theta n key or alpha f1. That's fine. I like the x t theta n, liking it. Type it in, x cubed. Get out of the power with the arrow key, minus 4x squared, minus 7x, plus 10, all over x plus 2. Is anybody having trouble with their calculator? Any errors or anything? Okay. Hey, that's why we're taking a lesson. Okay, and then when you're ready, you can hit graph. Did I type that right? Yeah. Okay. All right. Double check all your signs. Make sure you're good. And now we need to know the limit as x approaches -2 of f of x. So we're going to go to second table. Does everybody have it typed in? So go to second table. And we're examining what x value? -2. So we scroll down to -2. I'm going to give myself some room. I put my cursor on -2 because that's the value where I want everything to spread out. I want delta table to be based on -2. Yes, because I want to see there's an error there and I don't know what's going on. There's a lot going on between the y values of 32 and 12. So I need to figure that out by doing a delta table. What's the shortcut again? What do I push? Plus. If you forget, you can always do second table set and you can adjust your delta table there. Like I can put 0.001. Okay, I'll just do that, 0.001 and hit enter. And we go back to second table, but it's more convenient just to hit delta table. Oh, it moved it to, oh, you know what? I messed it up. It had my table start on 5. I went -2. Okay, so I'm on -2. Okay, we look at approaching from the left. We just put a few values in here for x. So we're going to make delta table is 0.001. And so that's going to be what, 2.00, -2.001, -2.002, -2.003, and so forth. And then on the right side, we have -1.999, -1.998, and -1.997. You could also, you could make this a little bit more diverse by doing by changing your delta table. Like you could make it you could do 1.9, 1.99, 1.999. So that's another way you can do it, but I just think it's quicker this way. So I like this. Okay, what is the value at negative 2.03? We get 21.03. And then we move to negative 2.002, 21.02, 21.01. And then this is an error. It's going to tell you error because what's happened is either, well, you saw the graph, there's no asymptote, right? So what has happened then on the graph? It's a hole, right? You've canceled a factor, so there's a hole. So anyway, that's really what's happened. And we'll talk about that when we get to the algebra portion. But there's an error here. So on the right, we look at, just put in your values, 20.99, 20.98, and 20.97. Okay, from the left, what value does it look like the function is approaching? What is the limit? 21. What is the limit from the right? Also 21, right? So I can safely conclude the limit of f(x) as x approaches -2 is 21. What do you think if I asked you this next part, part B? The limit of 2 times f of x as x approaches -2. What do you think you do? It probably is what you think. 42, right? You multiply them, right? 42, the answer to life and everything, if anybody catches that reference. 2 times 21 is 42. That's all you do, okay? That's a little hint into like the limit rules, but cool. Questions for me? All right. You guys want to try one all by yourself? See how it goes. Go ahead and clear your function. Type this in. I'm going to type mine in while you guys are typing so that I have it ready. Yep.
Like I'm already at the table.
Second quit, like if, or, oh, you mean go back to the table itself?
Yeah, like the base table, like the first table I see.
Probably second graph, which is like your second table. The base table? Oh, okay, so second table set, if you want to adjust it, so if you wanted to start at 1 and then like make it the table value. Oh, okay. So then what do you want to do? Okay, so you want to be on 2 and then well, no, what do you that's the change. Like you want it to be a really, really small value. Because the idea of this is if we have a really, really small value, we see what's happening. Very small values. Yeah, then we have a more. We doing this group?
See?
We're doing okay over here? Okay, I'm gonna graph mine. So what's happened is we have a hole in the function. We've canceled the factor x minus 2 if you were to factor that. And if you hit second table, we're going to examine as x approaches +2. So to get back, I'm going to hit delta table and then 1. And then go to x equals 2. And I hit the plus sign to change it to 0.001. The idea is to find a limit, we look at very, very small increments, right? The change in x. So it looks like for the x values, 1.999, 1.998, you would have 7.998, 7.999.
Lift his lips.
I just had two values on each side. Ladies and gents, what is the limit of f of x as x approaches 2? 8, right? So if you were to substitute 2 into this equation, what would happen if you were just to substitute 2 in? It would be undefined. Could you figure out what the limit is by plugging it in? No. So sometimes we can figure it out by just plugging it in, which I'm going to teach you next. But a lot of times if you can't, you look at the table and you see what you can see. All right? All right, next, substitution. Here we go. Do I have enough time? Yeah, I got plenty of time. Okay, so I don't need this anymore. All right, next bit. This goes into section 3 in the book. Using substitution to evaluate a basic limit. So I'm picking one specifically that don't divide to divide by 0 and all of that. You will see ones later that it does. Okay. So if I asked you to evaluate the limit of 2x as x approaches 2, what do you think you'd do? What will we do? It equals. Yeah, wouldn't you just plug in 2? Right? So this would be 2 times 2 is 4, and that's the limit. Is that easy? Yeah. Go into the your turn problem. Find the limit of 3x plus 2 as x approaches -3. Plug it in, plug it in. Hey. Are you on summer course or?
We might have some difference today because Thursday, but the rain. It's supposed to rain all day Wednesday and Thursday. This is hope so.
All right, what'd you guys get? Do you plug in 3? So -9 plus 2 is -7? Good? Okay. Oh, look at this. Trig. Ooh, trig limits. Okay.
It's 0.
You think it's 0? Because the sine of 0 is 0. The cosine of 0 is 1. The tangent of 0 is 0. And cotangent's the undefined one. So yeah, this would just be the tangent of 0, which we know is 0. Right? We look at the unit circle, the coordinate at 0 is 1, 0. Tangent is y over x, it's 0. All right, your turn. Do the limit of sine of x squared as x approaches 0.
0.
You said 0? Sine of 0 squared. Okay, we know sine of 0 is 0, so 0 squared is 0. Are they always going to be 0? No.
Yes.
No. Okay, so hey, from here, you can go ahead and do the practice that's there. 1.2 to 1.3 worksheet 1.